G'day Year 10s, welcome back. This is exercise 8D. With everyone back in the staff room today, you'll be pleased to know that you don't have to look at my little face up in the corner. So just the maths today. Let's have a go, see how we're going with conditional probability. Make that a little bit larger there. All right, so we understand regular probability. Now we're looking at conditional probability. It's written this way, and the way we'd say that is the probability of A given B. So that's the situation where we want to find out the probability of A, but we already have some information. We know in this case that B, whatever B happens to be, is true. And so the rule for this is you find the probability of A and B, the intersection of A and B, and divide it by the probability of B. Or if it was reversed, probability of B given A, you still find the probability of A and B, and this time it was given A, so you divide by the probability of A. And there you go, they're trying to simplify the rules there. So the number in A and B divided by the number in B. So these rules, if you're looking at a Venn diagram and you can count the number in each one, that's fine to do it that way as well. Here's an example of the probability of A. It's that darkest shaded section. There's set A. I might just colour it in because it's sometimes a bit hard to tell there. So there's A, and that's being divided by, so it's that, the number in that circle, outside of the total number everywhere. Probability of A given B, we're restricting ourselves just to circle B, so just to the area inside circle B, and then the probability of A, given that we know B is true, I'm finding that portion of the number within the circle. Anything outside that circle, I'm not interested in at all. Let's have a look at an example to make it clear. So going through these questions, find the probability of A. Doesn't really matter what this is for. Inside circle A, we have 3 plus 2 is 5, out of a total of 5 and 4 is 9 and 0. So 5 out of 9 would be the probability of A. I'm sure you can already see that. Probability of A and B, the intersection of A and B. Well, the intersection is that little bit there. There are 2 of them. So it's going to be 2 out of 9. Now for C, the probability of A given that B is true. Let's use the rule first of all, and then I'll use this little Venn diagram to show you how it works. So the probability of A given B is the probability of A and B divided by the probability of B. Now the probability of A and B we just figured out was 2 out of 9. And the probability of B, let's check, there are 2, 3, 4, 5, 6 out of 9 there. So 2 out of 9 divided by 6 over 9, 2 ninths multiplied by 9 over 6. Bit of cancelling here, and we are going to get 1/3. Now again, they showed you could do it just by counting the numbers. So if I move that across a bit, let's just look at another way of doing that. Probability of A given B, the number in A and B, divided by the number in B. Well, how many in A and B? 2. How many in B altogether? 6. So it's 2 plus 4. Oh, 2 out of 6 is 1/3. So that's a slightly faster way. The way I would tend to do it when I'm looking at these sorts of questions, I'd be saying, let's get out a nice thick black pen here. When I've been asked to find the probability of A given B, I get rid of everything else. We are only interested at looking inside circle B. I've been given that circle B is definitely true. So now I'm only looking at that circle. What's the probability that something is in A given it's inside that circle? And you can see straight away that it's 2 out of the 6 in the circle altogether, or 1/3. So I find it a little easier to do it that way. You can just cover it up with your hands. You don't need to black it all out in the exam. I'd just be covering up that circle with my hand. Similarly, for part D over here, oh, can you hear that? That's the new, they're getting all fancy with the school bell here today. There you go. I hope that was saying work, 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 because we need to do our work. We need to do our maths. So let's finish off this one here. Probability of B, given that we know whatever A is true. So I'm only looking inside circle A. How many of the elements inside circle A are also in B? There are 2 of them. How many are inside circle A altogether? 3 plus 2 is 5. So 2 out of 5. Again, if it helps you, you want to cover up everything other than that circle. I'll simulate covering it up by blacking everything out, basically. Now you can see probability of B given A, there are 2 outside of the 5 in the circle as a whole. Hence the probability of B given A is 2 out of 5. There's one for you to try there. Pause the video and try that now, and then come back and see if we agree on our answers. Okay, and there you've got your answers there. You can check. Just pause and check your answers. We're going to move on. So finding conditional probabilities using a two-way table. So from a group of 15 hockey players at a hockey game, 13 played on the field, 7 sat on the bench, 5 both played and sat on the bench. So let's fill in what we know. 15 total. Now they've told me here event A is being on the field and event B is sitting on the bench. 13 played on the field. So my total for on the field must be 13. 7 sat on the bench, so the total for sitting on the bench must be 7. And 5 both played and sat on the bench. So that's going to be A intersect B, that's going to be 5. From that, we can go ahead and fill in all the other values. Obviously, 5 plus 2 more is going to make 7. 5 plus 8 is going to make 13. 13 and 2 is going to make 15. 7 and 8 are going to make 15. So there's no one who both was not on the field and not on the bench, which would make sense. It would be very hard to be neither on the bench nor on the field. So that sounds pretty good. We look like we can do it there. So we've done part A. Find the probability that the person only sat on the bench. So the bench and not playing, that would be 2 people there. So for part B, the probability they sat on the bench and they were not on the field is equal to 2 out of 15. Part C, find the probability that the person sat on the bench given that. So we know that they played on the field. So probability they sat on the bench, given that they played on the field. So in this case, I'm only looking at people who are in set A. So if you like, I'm just blocking out those bottom 2 sections. I don't know if it's an easy way for me to actually block these out. So in this case, you would then block out and only look at set A. So if we do that, we're only looking at that top row there. You can see the probability that they sat on the bench and played on the field would be 5 out of the total of 13. Now, I've got to get rid of all that blacking out. So we can do the next one. But there we had it. It was 5 out of 13. And lucky last, part D, the probability the person played on the field given they sat on the bench. So now we're only looking in, if it's going to let me draw, it doesn't want me to. Okay, I'll do it from underneath. We can trick it. We're only looking in this column here, aren't we? The people that, given that they sat on the bench, we're only interested in that. What's the probability they also played on the field? So in this case, it's 5 out of the total of 7. And there you have it. All right, there's one more for you to try there. Pause the video and you can check your answers in a second. And then get on with your quick points and the rest of the exercise. Good luck today, guys. Cheers.